The formation of images in a convex lens. Objective: to learn how images are formed using a convex lens. A convex lens is a transparent optical device used to refract or bend rays of light in such a way that they converge on a single focal point. The lens is structured so that it bulges noticeably in the center. If both sides are bulged, it is known as a biconvex or simply a convex lens. Because of the convergence of the light rays which are refracted through it, it is known as a convergent lens. The refracted light passing through the convex lens forms images based on the location of the object in relation to the lens. Let's take a look at some different ways that images are formed using a convex lens. As rays of light pass through a convex lens, an image will be formed when the refracted rays converge at one point known as the focal point F. The distance between the focal point and the center of the lens is known as the focal length. In this situation, the image that is formed will appear only smaller than the original object, but it will be inverted. Now, let's experiment with the object's placement. If it is placed between the focal length f and twice the focal length 2f, the image will form beyond 2f on the opposite side of the lens. The image will be larger than the original object and it will be inverted. Because images like this can be projected onto a screen, it is known as a real image. If the object is moved farther back and placed at 2f, the image is also formed at 2f on the opposite side of the lens. In this case, the image will be same size as the object, but it will still be inverted. And once again, the image can be captured on a screen, making it a real image. If the object is placed anywhere beyond the 2f point, the image will be formed somewhere between 2f and the focal point f on the other side of the lens. In this case, the image will be inverted and much smaller in size. Once again, this image can be caught on a screen, and therefore it is a real image. If we bring the object significantly closer to the mirror, placing it between the optic center O and the focal length f, we will notice significant changes. The image will now form on the same side as the object. In this case, the image will be larger than the object, and it will now be upright. However, the image cannot be captured on a screen, meaning it is a virtual image. When the object is placed at the focus F, no image will be formed. Because of the location of the object, the refracted rays cannot converge or diverge. Instead, they will simply travel parallel to one another for an infinite distance, unable to produce an image. Summary: convex lenses form real and inverted images depending on the location of the object. Light rays from infinity will converge at the focal point of the convex lens. An object at the focal point will form a virtual, enlarged image on the other side of the lens. An object within the focal point will form a virtual, enlarged image on the same side of the lens.